Okay, I think we are good to go. So if you guys could grab your seats while you can, it's time to start. So I'm seeing a lot of familiar faces, but a lot of new faces. Talking about familiar faces, a lot of new faces. Thanks for joining us. It's a pleasure to have all of you here. So if you need a Wi-Fi access, you have the information on the first slide for our guest network. And tonight, it's hard to tell. Sometimes it confuses me when it's still bright outside. So we have 4 talks. So first, it will be Owen Sullivan talking about software development. He'll talk about monitoring of microservices. He works at Workday. Then we have John Malone from Boxever. He'll be talking about monitoring AWS spend with Python and wavefront. Then we have Anatoly that works at Zendesk with Filipe that also works with us, talking about implementing Nginx Fabric Model to reuse TCP connections and offload encryption for remote services. And then we have Deva, is that right? Deva Naidu from works at Naidu. It's positive leadership and performance coach. And he'll present, I'm not sure because it cut a little bit. Yeah, like the screen's not big enough to fit. So just to remind everyone, I have a couple of points. I would like first to remind everyone about our code of conduct. Alberto is not here. Usually he's the one that reads this. He's enjoy reading this. But I will read the short version of it that is, our conference is dedicated to providing a harassment-free conference experience for everyone, regardless of gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion or lack thereof, or technology choices. This is really important. Like, we are not here to like harass anyone just because they use Windows or something. We do not tolerate harassment of conference participants in any form. Sexual language and imagery is not appropriate for any conference venue, include talks, workshops, parties, Twitter, and other online media. And the conference participants violating these rules may be sanctioned or expelled from the conference without a refund. Like maybe you need to give back the beer. I don't know. Discretion of the conference organizers. Just a reminder, like I hope that we don't need, but we have the 2 exits here, one here near the kitchen and another one in the back of the room in case of emergency. The bathrooms are on the hall, like as you come in front of the elevators, we have the bathrooms. We will not be streaming today, but this will be recorded. So like if you have any problem that you don't want to appear, you like privacy issues, please let us know, because usually we take pictures, speakers may record, so like it's good to let us know if you don't like to have pictures taken of you. And I would like most of all to thank you for your presence. I would like to say thanks for the presenters for being here. Thank you very much. We would not be here without all of you help. Like again, as I said, this is a conference that is made by the communities for the community. So we are here exactly to have the community speaking, talking. So if you have anything that you would like to present, that you would like to share with the people like from the meetup, you are more than welcome to contact me or Alberto, and we'll try to get you on the lineup to talk and to present. So like we are here to say, oh, but I never spoke in any conference before. Don't worry, we are here exactly because of this. It's to help you, to have your first time talking, to improve. Like this is exactly not only to share technical knowledge, but also to help you if you need to improve while talking, while speaking. And we are here exactly to support you. Thank you very much. So first of all, I would like to call Owen here. That will be our first speaking from Workday. Thank you, everyone. If you want this one, usually is not as loud as this one, so probably.
Okay.
I like this better. People hear you better, usually. I think you have charger here.
Okay, outstanding.
Just in case. Murphy. Just a second. It should, let's see. Oh. Try this one. Yes. And I will be over there, so I have like a paper when it's 10 minutes before I will warn you.
Outstanding.
Awesome. Thank you.
So thank you very much.
I think it's already gone.
Okay. And thank you very much to Nginx for hosting this and giving me the opportunity to speak tonight. So I am Owen. I'm with Workday. I'm part of the monitoring team at Workday. So we're responsible for providing the infrastructure that monitors all the host services and applications of all the other teams at Workday, and provides two basic sets of use cases. The first is graphing, so providing a way for teams to visualize metrics in a graphical format. And the second is alerting, so when something goes wrong, that somebody gets called at 3 a.m. to do something about it. So I was in Florida in June of 2015, and I took the opportunity to go down to Cape Canaveral, to the NASA facilities. And I was there to see a rocket launch. It was a Falcon 9 that was operated by SpaceX, and they were bringing 1,800 kilograms of supplies and food up to the International Space Station. And it was really interesting to see the launch, to see the rocket go up over our heads, and then within 2 minutes to see it explode into 1 million pieces as one of the helium containers became loose and moved around, causing enough damage to completely destroy the rocket. So that they eventually found out that the root cause behind that was that one of the suppliers to SpaceX, who had supplied struts, which are basically a 2-foot-long piece of metal, hadn't monitored their quality in the way that they should have, and supplied a defective part and caused the complete destruction of that Falcon 9. And more recently, I was in bed at 3 a.m. and got a call because our service was impaired and returning 500 errors. And we engaged in the war room and started looking at the problem. We found out pretty quickly that we were not the only service. There were several services impacted. And it turned out that there was a networking change had been introduced. It had incorrectly partitioned the network, and services weren't able to talk to each other. So the networking change was rolled back, and all the services returned to the normal health, except for ours. So we had to continue troubleshooting, and we did. We looked for problems with our dependencies. We didn't find any. Problems with our backend database, didn't find any. Problems with anything that we had introduced in terms of software changes, didn't find anything there. What we did eventually find out after a lot of grepping of logs and painful troubleshooting whilst we were under a lot of pressure was that what had happened was the requests had been put into a queue while the network was partitioned, and there was a long retry timeout on that queue, and therefore when the network came back and new requests came in, they were put at the back of that queue. And we dealt with, unfortunately, that queue on a FIFO basis. So we were taking requests first in, first out. And what that meant was the new requests were being put behind the old requests in the queue and waiting for that timeout period to complete. And the end result was that we had that long queue and weren't servicing the requests. We didn't know it until we had grepped through the logs because we didn't have a metric on the length of that queue. So the takeaway for me from those two different stories is that monitoring gives you visibility into actual and potential problems and can help you either avoid and or mitigate problems and help you have an easier life in production. And that's the reason that my job exists and the reason that we're here for this talk. Okay, so I thought we would have a quick look at one demo app, which is a little client which makes a request out to Glassdoor, gets back some data, which presents the work-life balance for the particular company that was queried, passes it through rack as middleware and out to a server, and then I've instrumented that demo with, in this case, Prometheus as the monitoring tool. So So here you see the code, the key bit of the code that is making the query out to Glassdoor and contrasting, in this case, two companies, Workday and the US Army. I'm hoping there's no one from the US Army here tonight. So here we make a call into this little client app, and we get back some data. We parse the results and compare the two companies that I selected. You can, at your leisure, take this code and substitute in your own company if you so wish. And then we make a query into the endpoint that's being exposed by Prometheus, which is the metric collection technology in this case. And you can see up at the top of the screen, one of the metrics that we're exposing is demo number 3, with a value of 3. So if we go back to the demo again and then repeat, we come in here, and you can see we've got now a value of 4. So we're incrementing the metric each time. In this case, it's a simple counter, but we can, if we wanted to, use different metrics like histograms, gauges, summaries, that type of thing. And you can see further down in the screen, there are some more complex metrics there. So that's a simple client with instrumentation, in this case using Prometheus. And then we can look in the Prometheus console and look for our demo metric, and we can see it has a value of 4 here, and we can graph that. We can see its value over time. So we use that Prometheus technology for metric collection. We don't actually use that server for visualizing the metrics so much. We normally use instead a graphical tool called wavefront, which provides nice time series capabilities. So we can run mathematical queries on the graphs. We can visualize data for the periods of time that we want. We can zoom in and out, and it's a sort of collection agnostic technology. We use it for visualizing metrics we collect with Prometheus, with Sensu, with Nagios, and a few other technologies also. Okay. So maybe just to take you through some of the problems that we've encountered with monitoring and metric collection, and some of the gotchas we ran into as we try to manage and monitor our network. Our history has been that we started off with quite a monolithic application, and we've, in the last couple of years, sort of migrated away to a microservices environment. And as we did so, that mandated some changes for us in the monitoring team. We had been using Nagios, and Nagios is a metric collection tool. It's quite commonly used, so people here may be using it. We found some problems with it. So we found it was difficult to use, it was slow, and we replaced it last year with a tool called Sensu. And that allowed us to reduce down our granularity of metric collection from 7 to 1 minute. It made it easier for our teams to generate checks, and it was also more reliable technology, we found at least. So that kind of solved part of our problem, but not the full problem. And the reason it didn't solve the full problem is because, at least for us anyway, there's kind of two ways of looking at metrics and monitoring. So one is instrumentation from the outside, so looking in at the client, running some type of check that goes in and checks something on a particular port or runs a query on a host to grab a piece of data, but from the outside of the application inwards. And that's what we had with Nagios and Sensu. And the other sort of way of dealing with monitoring and metric collection is to have something from the inside of the application, that you instrument your code and you emit something that is important to your application. So with the move from Nagios to Sensu, we sort of had the first piece of that puzzle pretty well solved, and that was fine for that part. But we still had no way to meet the demand from our service teams, which they expressed as a need to instrument their code and be able to emit metrics in that way. And they wanted to work in the environments that they were used to. So Java developers wanted to work in a Java environment, Scala developers wanted to work in a Scala environment, and so forth. So we still needed some solution for that problem. And to solve that, we introduced a tool called Prometheus. So Google uses Borgmon as its monitoring tool of choice, and Prometheus is the open source equivalent of that. So it is proven at Google to be quite scalable. They use it across the company, and we're quite satisfied with its scalability. We have found that the client library that ships with Prometheus is usable, and our service teams like it. So we have introduced Prometheus to solve that second piece of that puzzle. The next gotcha that we encountered, though, was even though Prometheus gave us a solution for that problem, Prometheus is a pull-based technology. So it means that it needs to know what endpoints are out there to know where to scrape metrics from. So in our environment, we spin up VMs and shut them down all the time, and it's way too sort of scaled up to deal with that in a manual fashion. So we needed a solution to allow service discovery, and we chose to use Zookeeper for that, which is so the way we use it is that the services register with Zookeeper when they start. They register an endpoint that they expose their metrics on, and then Prometheus comes in, grabs the dump from Zookeeper, and then knows the endpoints that it goes out to scrape metrics from. We found a couple of gotchas with our use of Zookeeper, which you may or may not hit if you're using Zookeeper. One is that even though a lot of our service teams were using Zookeeper, they weren't registering a metric URL. So we needed them to change to expand the amount of data that they were registering within Zookeeper. So that was a change that was enforced on our service teams and was necessary for us to be able to grab that extra piece of data. The second problem that we had, and this is maybe something sort of within Workday, but we didn't expose a JSON API from the Zookeeper service that we were running. And what that meant was we didn't have a JSON API that Prometheus instance could query, and we prefer to use JSON. So we had to work with our own Zookeeper team to provide that JSON API and allow us to grab the data. And then the third and final problem that we encountered with Zookeeper was that the data we were exposing in terms of what services we could query, we were only getting a full dump of it. So that means we weren't getting just the changes each time, which is quite inefficient for us. So we, again, had to work with our Zookeeper team to to get them to change what they were providing to us. So that was kind of the third gotcha that we encountered, and that you may or may not encounter. Your mileage might vary in that one, but certainly they were the three for us that we hit. Okay, so one of the other problems that we encountered was a kind of a user problem, let's say, if you want to call it that. So the spike that you can see on the graph there corresponds to the introduction of Prometheus by one of our service teams. So they added Prometheus to capture metrics from their service, and they including, for example, 15,000 MySQL metrics. They actually only wanted one MySQL metric, but they added 15,000 new ones and a bunch of other metrics as well. So what we saw was an immediate spike in terms of our usage, and that's just for one silo for us, with no actual real extra value in most of the metrics that were added. So what we found is that the metric sprawl problem gets worse the easier you make it for service teams to add new metrics. And we needed, apart from the technology, user training to work with the developers to try and get them to a point where they were adding metrics that were of value, but not more, at least not much more. And before we went through that user training, we were getting metrics that we were delivering in with of questionable value, let's say, for many of them. And that just made it harder for everybody using the service, and made it it was kind of a waste of our service. Okay, so I have made a checklist here, what I think are the key things that you might want to think about if you're dealing with monitoring, let's say, especially in an environment where you've got a lot of change. So one is graphing of metrics. So we found that we needed a tool that provided a good solution for graphing of metrics that allowed us to run complex queries on those metrics. The tool we're using, at least, is a tool called Wavefront. It's a SaaS product that provides very good visualization of the metrics and also allows us to run rich mathematical queries. Out-of-the-box dashboards. So we found that there's a huge disparity between the sort of skill level of the various teams. So we had some experts that were really good with dashboards and metrics, and some that we really had to push them to do anything with monitoring. So out-of-the-box dashboards helps them get up and running, especially for that latter group, nice and quickly. So that link there is a link, it's a video clip from Uber, who talk about a similar problem, a similar challenge they had, and how they went about solving it. It was quite an interesting video. The next is that we found that developers like to work in the development environment they're used to, and they don't want to have to work in a different language or a different development environment to deal with their monitoring and metrics. So our client library for each of the sort of languages that you're dealing with is integral to getting metrics highly used. So for us, that included Java, Scala, Python, Ruby. So at least those 4 languages, we needed a client library that was easy to use. So Prometheus, at least, we found gives us good value there. The next then is that once teams get beyond the sort of initial level of simple counters, like we saw in the demo at the start, they start to want more functionality quite quickly. So Gauge is one, so that they can have not just a metric that just keeps incrementing, but it can have a value that goes up and down, like a speedometer in a car. Histograms, summaries, these types of sort of more complex metrics are we found important for at least a subset of teams. Alerting then, and being able to control that alerting so that you can have different sort of varying levels of alerting. So how you get alerted, either by page or email or a webhook into something like Slack. We found that all those sort of configuration options were important for configuring alerting and having different sort of levels of alerting. At least in our case, we have both a NOC and DevOps teams, so they have different alerting needs. The NOC want to be alerted 24 hours a day. DevOps teams, in some cases, only want to be alerted during business hours for a certain level, and then 24 hours a day for other levels. So sort of being able to support that complex level of granularity there. And then we had been restricted to granularity of 7 minutes back when we were dealing with only using Nagios, and that was highly constraining actually for some of our teams. So giving them metrics at 1 minute intervals and in some cases 10-second intervals was really important for at least some of our teams. And then an easy way to find the stuff that they create, and that actually can be easier said than done. So a good discipline and process around naming of metrics, around hierarchies of metrics, agreement on what the delimiter in terms of hierarchies is, and being able to support different delimiters for different metric collections. For example, Prometheus defaults to using an underscore, Sensu and Nagios default to using a dot separator. So being able to have both those two things as a delimiter in our graphing tool was important for us. Okay, so that is it from me, unless there's any questions, and thank you very much for your time.
Any questions?
Just a very simple question. Usually I see Prometheus setup being set up with the Grafana. Do you consider Grafana as well when you're evaluating wavefront, which I actually never heard about it?
So we actually have one service team that is using Grafana with Prometheus, but by default we're using wavefront. We're using wavefront across the board because it supports all our collection technologies. Whilst we could have gone with Grafana, and probably technically, I guess it would have probably supported many of our needs, I think the fact that we had already deployed wavefront was it was just easier for us to go with wavefront. But if we hadn't, I guess we could have looked at Grafana more closely.
Thank you. Just wondering, how can you make customize those the alarms? So typically, say, how can you define the alarm rules files? How can you define the rules? which point you for empty define those rules.
Okay, so if I got the question right, it's around alarms and defining the alarm rules. So we actually have a couple of solutions for that, as it so happens. It grew up that way. It's not probably a good answer, but that's just the way it is. In one hand, we have the ability to create alarms in our tool, wavefront tool. And we can configure through its GUI the thresholds on which we want to alarm and what action should be taken when we do alarm. As it so happens, we also have alerts or alarms generated from Nginx and Sensu in a different mechanism. Again, the alerts are configurable in a different way. There, we're configuring them directly within the check script itself. I would say less configurable. Because we have different alarming solutions, we actually are trialing at the moment a solution from a company called Big Panda, which provides a single pane of glass for alarms from different sources. So that is the way we're attempting to get to a point where we have a single pane of glass for the alarms that we're generating from different sources. Bottom line, I guess, is that that's maybe a problem particular to us. You might not hit that. Not sure if I answered that question or not.
How do you spread the agent to make the servers see the monitoring servers? Do you install an agent? How do you deploy it? That's my question.
So if I understand the question correctly, it's how do we get... Do we deploy agents in order for the metric collection to happen? And how? Okay, so the how bit is, Chef is our configuration management tool of choice. So most of how we do that type of thing is done with Chef. Whether we use agents or not, yes, we do for Sensu and Nginx. So we deploy a client on each of the client hosts. And they are Chef managed, so they know through Chef the configuration settings they need to contact. For the Sensu client, it's actually a rabbit queue that it needs to get to. And that rabbit queue contains the information it needs in terms of checks and so forth. And Chef configures that way. Nginx is something similar. Prometheus is a bit different as a client library, and there the clients are registering with Zookeeper, and then our server is connecting to Zookeeper to get the list of endpoints it needs to scrape metrics from. So a couple of different answers, and that's just it grew up that way is the bottom line.
Thank you very much. I was going to call everyone out. I was waiting. So I'm seeing a lot of people standing behind. I mean, don't be shy. We still have some places in here. Like, don't be shy. Like, no one wants to sit close to us. But so next we have John from Boxever, and thank you for being here. And it's with you now. Thank you.
Thank you very much. Hopefully you can all hear me. I'm going to be talking about the terribly exciting topic of monitoring Amazon spending. I don't think that's top of anybody's list, but it is a problem we kind of all have to face. So I'll go through a bit about what Boxever, who we are. I'll go through a little bit about our environment, and I'll talk in more detail about how we came up with our current monitoring process for finance. Ultimately, we display our metrics. We turn our metrics, our finance spend into metrics in wavefront. So I'll go through a little bit of the process we went through to get to where we are now, and what I learned along the way, and what we have yet to do in the future. Boxever we are a company that we connect customer, product, and operational data for companies largely in the airline space at the moment. We ingest various event data from the company's website, from the back end, from batch jobs, and in return we provide real-time marketing to the companies via API endpoints. So we ingest in and around 1 billion events a month. We have lots of guest profiles stored, and we use a variety of technologies that you're probably familiar with: Java, Microservices, Cassandra, Kafka, lots of Amazon stuff, and we manage that infrastructure largely using Ansible. So it's a fairly standard environment, I imagine. So why do we monitor finance costs? Well, obviously, we want to control costs. We monitored our finance data ultimately in Wavefront because we've migrated to using Wavefront for our operational data. And there's a big win in having your operational data, such as stuff like CPU and RAM and disk usage is one side of it, but also your interesting application monitoring data in the same data source as your finance data, because then you can start answering interesting questions. So interesting questions such as, how much does it cost to process 1 million events? What did it cost us last month? How much does it cost us to store data for a particular customer? And by getting all that finance data as well as your operational data into the same monitoring source, you can start asking some interesting questions. So what did we do? Ultimately, it was driven by, the initial version was me tagging our infrastructure, and ultimately I was asking the wrong questions. So the second version was the engineering department, me talking with the finance department and finding out from them what they wanted to know, so that they were driving the process. They were the ones who ultimately were taking this data up to board level, and they're the ones that would really get the most benefit out of it. So they were coming up with these questions around, they wanted to know how much it costs us on an ongoing basis to process a certain number of events. They want to know how much it costs us to store data for customers. They definitely wanted us to spend less. When's it any other way? So ultimately, we had a very exciting process creating a budget. I will spare you the details of that. But in short, we came up with a plan for the year where we had lined up for the year what we were going to spend in certain areas that they were interested in, so that we were figuring out from the start what answers they wanted to get from our data before we started tagging our infrastructure. We have an ongoing process where we, again, naturally enough, you keep track of what you're spending and keep track of what you're spending against. And we were able to, by generating the data and putting it into Wavefront, we're able to automatically have dashboards in Wavefront that match this budget that we've come up with finance. So previously, we were able to extract the data manually from Amazon, but it was quite a manual process. There was lots of parsing of CSV files and getting intimately involved with Google spreadsheets, which nobody wants to do. So by getting things into Wavefront, you can avoid learning anything about spreadsheets, which is definitely a win. But the key to this is cost allocation tags in Amazon. Cost allocation tags are standard tags. Amazon allows you to tag your resources with arbitrary key value pairs, and you can nominate some of these key value pairs to be finance tags or cost allocation tags. And Amazon will provide you with a detailed breakdown of the cost of that resource. So for example, you can tag an Amazon EC2 node, and you get not only the cost of the EC2 node, but you also get the cost of the data transfer to and from a region, to and from an availability zone, a much more detailed breakdown of the costs associated with that node. So if this node is running, for example, Cassandra, you can know what Cassandra costs, and you can also know what the data transfer of Cassandra is. So it might highlight, for example, you're transferring a lot of data between availability zones, which is quite expensive in Amazon. If you're storing a lot of Cassandra, it will add up. Your replication costs will be quite a source of pain in the future. But with finance tags, you're able to get the required details out of your Amazon spend that you can use to keep control of your costs. And again, this tagging, you need to know, I found anyway, that you need to know the questions you want to ask before you apply your tags. It's very easy to go in and look at your Amazon infrastructure, think, yeah, this kind of makes sense, and you apply tags, and there's a lot about tags that make it reasonably difficult to use accurately, that I'll get to later. But ultimately, we came up with our budget, which was the answer we wanted, and then we tagged our infrastructure accordingly so that it was easy to get the answer out after we'd applied the tags. So finance tags, you can add a tag to a resource, but that doesn't necessarily mean it's going to be a finance tag. There's quite specific rules that Amazon have around what makes a finance tag accurate, and it's hard to know if you've tagged your environment correctly. So you can tag an EC2 node, but that doesn't necessarily mean that and you've nominated those tags as finance tags, but that doesn't necessarily mean that that is an accurate finance tag. You have to tag the resource after you create it. Tags only start appearing in your cost report after you've applied them, and various other rules as well that you only hit them when you've dug into this stuff in a lot of detail. But there is a need to keep a lot of monitoring and a lot of checks on whether your environment is tagged accurately, because the tagging is the key that what drives the ability to view the data accurately in wavefront later on. So as I said, we had ultimately the goal of presenting our data in our case in wavefront, and we wanted to be able to merge our operational data with our finance data. So Amazon I use the detailed billing report CSV. This is a CSV that Amazon provide to an S3 bucket you specify. They update it, I think it's a couple of times a day. It contains a lot of information. So this contains there's a line item for every billable object, if you like, in your infrastructure. So every EC2 node, the data transfer from every EC2 node broken down by every hour of your month. So if you have a reasonably large infrastructure, that's going to have many millions of rows and be many gigabytes in size. So opening it in Excel is not really practical. So in my case, it's easy to process this. It's just a CSV file. So I process this in Python, and I aggregate my costs according to my finance tags, and I emit InfluxDB metrics lines. So essentially, I'm just converting my CSV into InfluxDB lines. And we're using Telegraph, which can consume metrics in quite a lot of different formats and emit and upload those metrics to a lot of different syncs. So you can send it to Prometheus, you can send it to Wavefront, Graphite, you can send it to all sorts of places. So it takes the data in our case, in InfluxDB, and we're sending it to Wavefront, but you could send it anywhere you wanted. So yes, in short, we process the CSV, convert it to InfluxDB, and send it to Wavefront. So once it's in Wavefront, we have the ability to create any dashboard we like. So this is spoof data. Let me make it bigger. So I've taken, this here is for the month of March, but and the figures are largely meaningless. But once the data is in Wavefront, we have the ability to analyze the data in any way we want using the powerful querying language that Wavefront provides. We can do anomaly detection, we can do alerting, and again, we can match and we can integrate this finance data with our operational data. So it's not necessarily interesting to wonder how much CPU usage a particular customer is using, but it is possible to break down and to ask and answer interesting questions once you have all of that data merged into the one format. So in our case, this provides a high-level view of the total cost over a month of particular items, and then you can dig down using Wavefront into, in our case, the particular applications and the particular logical units that make up that cost, as well as breaking down into what parts of Amazon, if you like, are causing you that cost. The query language in wavefront is fairly straightforward. And again, it's all driven by the finance tags that we created, driven again by the questions that business wanted to ask, is what the answers that come out the other end. We have more work to do. The things I've learned from this was, in order for the business gets a lot of benefit by knowing more than that you spend 10 grand a month on M4X large nodes, for example. That's not really an interesting, it's interesting that you're spending 10 grand on something, but they're more interested in knowing what a particular feature or a particular customer is costing or a particular KPI that they have. Without using finance tags, you can't really answer those questions. And defining your tagging policy in advance by knowing what questions you want to answer is key to getting benefit for the business units. Tagging process in Amazon is tricky to get right. You need to automate the addition of tags. We use Ansible, so when we automatically tag, for example, EBS nodes based on the tags that are on the node that they're attached to. You can't tag, well, you can tag EBS snapshots, but Amazon billing doesn't support breaking down the cost of those snapshots. So your snapshot costs will always appear as one big block. You can't say, I spent 5 grand on Cassandra's snapshots and $400 on Elasticsearch snapshots. The tags only apply from when you apply them going forward, so you can't apply them retrospectively, and there's all sorts of rules about getting tags right. So it's important to monitor and to keep track of your untagged spend. So again, in Wavefront, we have another dashboard that says what amount of spend we have that we haven't allocated to a tag, and you can go back and figure out that, oh, I forgot to tag this EC2 node, or you might spend a lot of time retagging your infrastructure if you haven't got it right the first time. Future work, as I said, the Python script I wrote is fairly straightforward. It's not that complicated. It simply iterates through the CSV, aggregating the data as it goes along. But I'll release the source for that. The next step for us is to start developing those dashboards that answer more interesting business questions. So marrying interesting data that comes out of our API endpoints, marrying the requests per second coming in with the cost of those resources, and providing automated dashboards to the business units that they don't have to come to technical people to dig out this, what can be complicated data for them to understand, for them to get out of Amazon. To add more alerting on tagging issues, and again to use Wavefront's anomaly detection to track this month's spend versus last month's spend, and generally put in more alerts on the financing spend. That is what I have. Any questions?
That's not a lot of questions. I was going to raise the point. No.
Thank you very much. Yes.
I'm going to ask two, if you don't mind. Firstly, how do you enforce proper tagging of the resources? I'm guessing Ansible is the answer, but yep. Okay. And the second is, how do you get down to the granularity of an individual customer? Is it that the resources are single tenant, if you like, or how's it done?
So for us, in regards of enforcing the tagging structure, certainly Ansible is key to that. We've got it wrong. I've got it wrong a few times. So Amazon provide there is a good tagging tool that's in some ways hard to find, but it will, something I don't say about Amazon's UI, this is actually a pretty good UI tool from Amazon that allows you to tag large amounts of resources efficiently. So that helps to fix problems, and using Ansible automation tries to prevent the problems in the first place. And then the second question on the granularity. So we have we're kind of a mix of a shared, externally it's a a shared tenant environment. So some of our services are single tenant. For example, we might have a Redshift cluster that has single tenant. And then there's other aspects of our environment that are shared tenant. So some of it is, it's easy when it's a single tenant. And if it's a shared tenant environment, you possibly in our case, we need to write, which we've done in the past in the manual process, where we write dedicated scripts to interrogate the Cassandra infrastructure, for example, and work out what percentage of the data is owned by particular customers and generating metrics, synthetic metrics, I guess you might say, so they're not directly coming out of Cassandra. If you have a Cassandra key space that's dedicated to one customer, then Wavefront will already tell you how much disk space that key space is using, how many I/O operations that key space is using. But if it's all munged together, you might need to figure out heuristics almost about, in our case, we know what percentage of our traffic comes from particular customers. So then we can infer that 40% of the data in this unknown bucket is from a particular customer. So depending on where your data is, you need to make compromises in how accurate it's going to be. Yeah, the compute side is, the compute bit is fairly straightforward. A lot of it, we know the volume of traffic coming in. We know very accurately that this customer sent us 1 million events last week. That is 20% of the total traffic last week, so they get 20% of the processing. I mean, this isn't some of this data is not data you're going to go to court on. It's not necessarily going to end up in an invoice. It's still interesting data for business to drive what can be quite critical decisions in a company around how much do customers get billed and all aspects of that side of the business.
Thank you. Just more of a detailed question. The reports that you get on the CSV, do they include the pricing? And the question is more in the sense, when Amazon changes pricing, is the new pricing reflected on those files?
Yes, he says tentatively. So Amazon generates this CSV, I think, a couple of times a day, and they'll tell you in their UI that the last 2 weeks of data or thereabouts are estimates. So you go to the data today and you look at yesterday's cost, and you'll see that snapshots were actually pretty low, and then you come back to, you wait a couple of days, and the snapshots will be much higher when they've figured out the details. Now, if you're talking about retrospective price changes, I don't know, but if you're going, certainly you need to keep processing that file for up to 2 weeks after the day, because I don't know the details of exactly what will change, but Amazon certainly moved the goalpost, and the data will change as time goes by.
Yep. I should just add something to that. So I work for Wavefront, and recently, it's what I showed you yesterday, John. Recently, we started adding, Amazon does have a pricing API, so you can interrogate this JSON and get the pricing for everything. And we've only done it for EC2 so far, but we've started emitting that as sample data. So all our customers have all the EC2 pricing data that Amazon provides just built in. And you can alert when if they change their prices or anything, you can be notified easily. We'll add the rest of the services at some point.
Thank you.
Not Spot, but not yet. Just on demand.
Did you try Trusted Advisor and Amazon Cost Explorer, because they give the same kind of picture?
Yeah, I use Cost Explorer a lot. I guess the reason I chose to go with importing the data into a tool like Wavefront is that it provides us with a lot of flexibility around marrying resources from a lot of marrying monitoring data from a lot of different data sources, such as your operational data, your intimate application metrics, where it makes sense. You can then combine them with your finance data. The data in Cost Explorer provides good summaries, but it doesn't provide the same level of the same power that the wavefront query tools do. And then the data is somewhat siloed away from your operational data, so it's hard to answer. You need to export it into nasty spreadsheets to kind of combine things. We have again, because all our operational metrics and alerts are already in wavefront. So that's the technology we've chosen as our single monitoring solution. We're migrating away from 3 other monitoring solutions. So another one of the goals is to reduce the number of tools we're using and to combine them into the one place.
I'm interested to know about the story to get this infrastructure and all this technology for monitoring costs. As going from an evolution of a company that goes, there's some pricing model, and it's fine, we kind of get the prices right, but then we grow, and definitely the cost control it is more difficult, and then there's some need to put something in place. I was wondering, or I'm interested to hear about the story when there's in the time in the company, we really need to educate time engineers to come up with something that we actually have an idea how the money is going.
Yeah, I guess. I suppose it comes with the evolution of any sort of startup company, where the early days here's a check, here's a credit card, and go spend money and come back later when we see what it costs. And as our company evolved, and as the bill got bigger, it became evident that we needed to get a handle on reducing the Amazon spend. And I certainly explored external tools, such as there's a whole variety of tools that will promise you all sorts of things around managing your cost. You give them a 5% of your bill and they'll reduce the cost, and largely that's around just reserve everything and we're all winners. And it's not that simple. You've got new projects that are coming online, so you don't know what exact hardware you're going to use. You've got old stuff that's dying, you have reservations expiring, and it's just not as simple as reserve everything. There's going to be stuff on demand, and it ultimately requires you can provide. It certainly helps to provide dashboards and tooling, but you need to provide people. Somebody needs to sit there and figure out, why is this running on demand, and did somebody leave the lights on in there, and why is there 10 terabytes of data in this bucket? And but yeah, ultimately the bill gets bigger and you need to get a handle on it, and at the same time your company's billing structure might be changing. You have new products coming online, and you need to get a handle on what makes sense to charge customers in the future and what things are costing you as a company. And the business isn't really interested in how many M4X larges you're running, or they want to know what an application is costing, what a feature is costing, what a customer is costing. They want the data chopped up in 50 different ways. And unless as the engineer you understand what answers the business want, you're not going to be able to provide them with the right data. So it's important to sit down with the accounting people and the finance people and iterate and explain why we can't do it this way and why we have to do it that way. And it's a long process. And it's not there's more interesting things to do than digging into 5 gigabyte CSV files. But there is benefits at the end of the day.
People like it.
That's their choice.
Well, I think this includes on the technology choices. We can say anything.
Yeah, exactly.
Do you have a person full-time doing this monitoring for
No. So in previous iterations, it was manual. We'd have a monthly meeting, and I'd write scripts and create the most horrible spreadsheet I've ever seen in my life. And ultimately, that was the process. Yeah, and then that pain was too much. So now there's a Python script that parses CSV and produces graphs. So now I don't have to produce 3 or 4 days of work to produce the horrible spreadsheet. Now there's graphs, and now the next phase is to start answering the other questions that finance has, marrying the different data sources together around data that we come in, data that we take in and spend, and answering their interesting questions that way, with less days spent in Google Sheets.
Any more questions?
I suppose you are using AWS resources in order to process the data on the street to provide provide the information, right? So are you tagging those resources with causal allocation tags as to know how much, more or less, it cost for you to provide that information? On the other hand, are you using something like serverless infrastructure like Lambda or something like that? Or are you using, for example, spot instances in order to lower the cost to provide that information?
So we use both. So we use EC2 instances. So we don't use Lambda at all, I don't think. So it's just EC2 instances. We use both normal instances and spot instances. So we have EMR infrastructure that uses quite a lot of spot instances, and they get tagged with finance tags as well. So when you create the EMR cluster, you assign the relevant finance tags to that EMR cluster, and every resource that EMR cluster creates will get assigned those finance tags as well. So again, it goes back to one of the previous questions around shared tenancy. If you have a big resource that's doing lots of things to lots of people, you can tag that infrastructure at a granular level, but at a high level, but you can't necessarily get down to the real low-level details unless your code is instrumented to then emit other metrics to maybe break down that this EMR cluster was half the time used for customer A and 25% for customer B, and you can use heuristics, if you like, to drill down further if your finance tags don't take you all the way.
Did finance come up with any interesting actions out of it? Did finance come up with any interesting actions or insights out of the data that you can share with us?
Surprisingly, the key message. I mean, they certainly got a lot of this. When you look at the data, when you provide this data, previously we were simply providing, there's an Amazon bill at the end of the month, and that's kind of largely as much as finance took out of the whole process. But now they have far more visibility around what different parts of the business are costing from an Amazon point of view, how much data costs to process, how much data costs to store, what different technologies are costing more money. So it also drives engineering to drive our efforts to reduce our costs by migrating away from expensive infrastructure and moving more to cheaper infrastructure. Spot instances, processing data from S3 as opposed to leaving it in Cassandra, for example. Thank you very much.
Thank you. So now, first I will do like 2 minutes break if someone wants to go to the bathroom or grab a beer or something. Like 2 minutes, and then we get back here with Anatoly and Filipe. Because like we are in Ireland, we need to grab a beer. Thank you very much.
I have also bought some notebooks and pens. If you're quick about it, you might get a notebook or a pen. Luke.
If you want swag, just come here and poke John. I'm Cassiano. Nice to meet you. I'm good. I'm good.
Thank you guys for
1 extra minute. Just letting everyone know if they want to grab beer or something, go to the bathroom. Or if you want some snack while the pizza arrives. Okay. Looks like we're... I was checking if it was turned on. Let's grab our seats. And now we have Filipe and Anatoly. They work at Zendesk. We'll be talking about Nginx Fabric Model. Thank you very much for the presentation. And now it's your turn.
Hello, everyone. Can you hear me?
No.
Hello?
Hello. Just need to put it closer.
Hello. Okay. My name is Filipe. He's Anatoly. We work for Zendesk. We are not DevOps, so that makes us intruders. We are software engineers, and we're here today to talk about a little bit about the Nginx Fabric Model. We are mainly focused on one of our problems that we have with one of our providers. So it's not the whole thing, it's just more focused. So our context is we work for Zendesk as software engineers, and we work with Talk. So Talk is our product, our solution to do support for telephone communications. So PSTN, network, and all of that. Our system works with Nginx, Lua, of course. We use Ruby as a programming language, and also Go. And our main provider is Twilio. Twilio makes this bridge between our systems and the PSTN networks. And one of the restrictions that Twilio has that's very important is our requests. They need to be responded in 15 seconds. Any request that Twilio makes to us, we need to respond that within 15 seconds. And also, all the requests must be made in HTTPS. We cannot use HTTP at all. So yeah, that's our context. That's why we started looking at the Nginx Fabric Model. So here, initially I thought to display just this image and explain, but we decided to go to the New Relic actual page. So if you can switch your screen, yeah. Every time we connect to Twilio or Twilio connect to us, we have this crazy restriction of 15 seconds. And normally when we say 15 seconds, oh, that's plenty of time. But if you start troubleshooting, debugging things, as you can see over here, just the time between we connecting to Twilio or Twilio connecting to us, we have this network timing. And if you're in Washington, D.C., the network timing spent in the whole process is kind of 70 milliseconds, which is not very bad. And SSL handshake negotiations like 32 milliseconds, which is good. But if you are, let's say, in Dublin, not so good. Let's say Singapore, even worse. So independent of which technology we adopt, independent of which language, which stack, depending on the place in the globe our servers are, the network time changes. And that's a restriction we can overcome. So yeah, network timing is very important to us. Responding until 15 seconds, it's very important to us, and we cannot overcome that. And that's, that's for each connection. To answer a call, we do a lot of different round trips to Twilio, and Twilio to us. So imagine, for example, if we have a server in Singapore, we do 1 second for each request. Let's say we have 10 requests per call. We would end up with 10 seconds only to try to connect, only to establish the connections. So It's pretty big, pretty intense. Yeah, swap back to presentation. Yeah, so when we started to look at that restrictions, we said, okay, how can we overcome that? In looking at the Fabric model, first, as we can see into this picture, Fabric model is intended to solve a different problem. So what Fabric model is doing, it's Nginx approach to microservices. So as you can see here, we have a bunch of services, web servers communicating to each other through Nginx. So here, for example, the service for is zoomed. We have some sort of microservice here that connects to internal Nginx, and internal Nginx connects to the other services. So nothing related to external communication at all. It's just how your services communicate to each other. But we realized pretty quickly that to overcome our limitations in connecting to Twilio or any external services, we would need to have some sort of in-between. So the Fabric model, the way they are intended to, is to work on a microservices architecture to solve secure and fast communication, service discovery, load balancing, and resilience. So Nginx is trying to solve those problems. And we are trying to solve at least secure and fast communication to Twilio. That's our main focus. And then here, we normally implement Fabric model in two pieces. So to implement Fabric model, you need to implement what we normally do. Every single external communication through your server, through your application, or through your resource passes through Nginx. Pretty standard. External communication comes encrypted, and maybe you want to make things faster, you traffic inside of your network, inside of your infrastructure, unencrypted data. That's pretty standard, but that's just half of it. If you go to the next slide. Normally, when we implement that, we're just implementing it for inbound communications. In our application, to handle Twilio, we do both sides. We do inbound and also outbound. And our infrastructure initially was application. So this is like a Ruby application, Node.js application, any application. And this is an external service, Twilio or any other provider that you can have. And normally, our applications connect directly to our external providers. So for example, here, this application is connecting to Twilio. And what we normally do, we create a request, REST API, goes to here directly. The problem with that approach is, once you do that, the responsibility of improving connections, maintaining errors, maintaining monitoring is in the developer side. It's very hard to improve that from the ops side. Why? Because this is never going to change. Neither this. Ops don't have control over external services or application code. So how Fabric model tries to avoid that, tries to improve that connection. So if you move to the next slide, we introduce what we normally do, a proxy in between. But this time, not for inbound, for outbound. What's the benefit of it? Why we do that? Why this is important? Normally, when we develop connections, develop REST APIs or anything, we don't think about, is it going to be fast? Is it going to be reliable? What if there is a problem with it? We normally just, make a request, treat response, and that's it. So Fabric model tries to avoid that gap, creating this Nginx in between for outbound connections, because if you have an Nginx in the middle, you have a space of improvement. If you have Nginx in between to make outbound requests, you can change things. You can monitor things in a different way. So go to the next slide. The life cycle of an HTTP, everybody knows. We have a client, we have a server, we make a request, we receive a response, and that's how normal things works. But if you think about security communication, we just think about the data trafficking encrypted. But we always forget about what happens in between. To connect to Twilio, or any service to any service, we need to have the TCP handshake, which is the blue lines, and also to close the TCP connection. And also the SSL handshake, which is the client hello, server hello, key exchange, certificate. And also, like, this is just high level. If you have a certificate that has like different root authorities, you need to also get requests to those root certificate authorities sometimes. And that makes another round trips. And that's for each connection. So we pretty quickly realize, okay, if I have a server in Singapore and I have 10 requests to Twilio, I'm going to do, I don't know how many round trips per connection every time. So the solution's pretty simple. Implement Keep Alive. If you implement Keep Alive, you're not going to open and close connections all the time. Simple. The problem is our application, our technology, we were trying to implement Keep Alive into the developer side, and it's pretty painful. If we have different programming languages, different frameworks, that's pretty painful. A simple thing like Keep Alive. So if you think about the Fabric model again, if you have something in between, if you have a proxy in the middle, like Nginx, you have Keep Alive on the fly. It's not a hard thing to do. So we're gonna start a demo to present how things are working and how we set up this. But I think the main point is, right now, if you want to have some space of improvement or monitoring or things like that, it's very hard for us because we rely on coding, we rely on writing metrics, we rely on changing our code to make it more reliable. And now we are showing this concept of having this layer in between so we can remove this responsibility from the code or the connection itself to make sure we have a layer in between where we can manage things.
Hey guys, I'm Anatoly. I have a hoodie with Nginx, as you can see. It's a gift from my friend, from this guy. So, I use Nginx at least 7 years now, and my friend Filipe helped me to do this amazing idea. So let's do some live demo. So I'll start with Fabric Model in action. So let me show you what the Fabric Model is. Can you see my text? I can make it bigger. Can you see it now? Perfect. So let me show you 1 to 2 minutes of the Fabric Model in development. So we have a number of containers in development. Of course, we have Nginx. We have 2 Redis containers, 2 memcache and master and slave from SQL. So let's use, let's save data in Redis into containers. So, and then we try to get data from Redis, but we do it through Nginx. As you can see now, we have 2 containers, and we talk to Redis via Nginx. What does it mean? If you see the configuration, this is the upstream we have, right? Application never talks to any kind of external containers, any services. It talks to localhost all the time. And Nginx cares about which service is alive, which service is available. This is just introduction for Fabric Model idea. You can see Redis 1 is backup container, right? What happens if I stop Redis 0? And I will try to fetch data again. I'll wait a second, and then I receive data from second container. So what's the idea behind this? You should never care about which data storage is alive, which is fast, which is slow, which external endpoint you should use. You talk to localhost. This is localhost. If I start my container again, I'll receive data. Oh. I shouldn't make lab demo. Let's try it again. Yeah, I have no idea what happened. Anyway, this is like introduction for the second slide Filipe displayed on the screen. But the benefit for the fabric model for us is to have a Twilio endpoint exposed via Nginx. So we run Wireshark. And let me show you something. We run nearly 5,000 requests. Some of them went directly to the Twilio endpoint, which is api.twilio.com. Some of them went to Nginx, and some of them went to Nginx with Keep Alive. This is the magic. So this is 60 seconds per each run. This is the first run, second run, and third run. Can someone guess what the blue line is here on the screen? This is a TCP scaling window. Can someone guess what the green line is? Yeah, you could read it here if you want. It's how many bytes we send. This is raw data we got from running the test through Siege. We use a thing called Siege, which is much better than Apache Bench, because Apache Bench benchmarks itself, but not the endpoint. You want a benchmark? So that's the benchmarks we run. The first run is request to external endpoint from your application. You have to resolve DNS. You have to establish a TCP connection and SSL handshake every time. Second time you do it through Nginx, and third time you do it through Nginx with Keep Alive. Let me show you some data. So, important thing is we send the same amount of requests, 2,000, no. We actually do it, we send requests with 1 minute each time. First time we send 2,000 requests, 200, yeah, 2,000. Second time a bit less. Third time we sent nearly 9,000 requests. This is the same amount of time we spend, where we see only almost 4 or 5 times more throughput for outbound requests. This is like HTTPS encrypted requests. Like all of them get the same results, but the throughput is way higher. If you go back to slides, this is the numbers. This is how do we talk to external endpoints just every single day. 37 requests a second. This is how we do it through Nginx, 36. This is how we do it with Keep Alive. I don't know if anyone impressed. I was impressed. Because we do nearly a couple million requests a day to external endpoint. And the funny thing here, it's slower than this, but I must say that if CPU and memory, when with Nginx cares about encryption. on application level, we save CPU and memory dramatically. And if you keep alive, it's even better. What does it mean? If you employ this technique, you can not only save time, you save resources. Your bill gonna be less for the same amount of work you do. And if you work on the real-time applications like we do, you get benefits straight away.
Okay. That's the last slide. So from our experiments and our changes, we saw that we can benefit a lot of Nginx, of course. We all know that. But the way we implement that, it's extremely important. In this case, for example, just to implement Nginx as a bridge between our outbound connections, we got for free better DNS resolving, better CPU cycles, memory consumptions, just to move things from the application level to the proxy layer. So one extra benefit that we saw, abstraction. If our applications never talk to external communication, you see less errors. If you want to do some metrics, how to improve things, Nginx can handle metrics for you. You don't need to have external things. Retries. Right now we do a lot of retries. If something doesn't work pretty well, we try again. And that sometimes it's coded. We have code for that. We don't need with Nginx in between. And also, as I said, Nginx is more than capable of driving the metrics of our entire network communication. When we say, when we say network communication, I'm not talking only about REST APIs or external services. I'm also talking about how my application connects to my database, how my application connects to Redis, to Memcache, to any external service I want. Because Nginx can also proxy HTTP connections, but also, raw TCP data or any kind of data. So yeah. Thanks, everyone. The pizza arrived.
Countdown. Any questions?
Two quick ones. Can you show us the Nginx config again? And does the keep alive only work with Lua, or will it work with a standard Nginx?
You wanna? Okay.
I can speak about this one. So a configuration for this part, right, is that one. So you have like upstream section and a server with the your remote IP address, your remote service, and a port 443, of course. It means like Nginx will talk to HTTPS always. On the local machine, you talk to port 80 unencrypted, and you talked like through a location. You can specify any location you want, but internally it's going to be HTTP. Keep alive is a bit complex because you have to specify HTTP keep alive section in upstream block, and you have to say HTTP has to be 1.1 and connection shouldn't be closed. It's closed by default, so we keep it open. And this part, keep alive, and this port 81 give us 5 times throughput, which is this one. Oh, configuration.
Pay attention because you may do the opposite, break something.
Oh, you can always break stuff, yes. Actually, let me show you the siege I used. I basically called the icon file. So like I talked to like image file. I never talked to any backend on the Twitter site. which makes the test results correct. There is no slowness from backend, it's just a picture on their side. We test only the network layer, like we don't test application. We test just image, just an image. So let me keep it on, yeah.
So this is just an HTTP 1.1 setup, but I would be really interested if you guys have experimented with HTTP 2, because this setup looks like making many HTTPS calls down to Twilio and back, and I would assume that HTTP 2 could get some really good points.
Yeah. Can you show this slide with the
API doesn't make a lot of difference.
Oh, the services, the fabric model image from Nginx. Okay, this one. So this is the standard fabric model. Here we have services, and here we have, I don't know, it says pages could be like web services, like normal static files. So as you can see here, the benefit of having Nginx connecting to Nginx is that you can improve things regardless of what you have running here. So for example, let's say you have a Ruby code here. You can talk to your Nginx as Unix sockets. And this serves in Go, Unix sockets. And those two could say HTTP2 because Nginx can handle HTTP2. But once you're talking to an external service that's not over here, it's not under your control, it's very hard for you to test with HTTP2. So that's why we cannot test HTTP2 with Twilio, because apparently they don't support it. But between your stack, even though your developers can deliver that to you, you can make that connection work.
And I'm not even sure if Twilio will ever support, because for APIs doesn't make a lot of sense. HTTP2 for browsers make a lot of difference, but for API requests that you are just back and forth in a single connection, having keep alive and just using a pipeline on this, it will be like the most performance you can get no matter which protocol you use. Like, and then you can enable, for example, compression over this and use gzip on top of the HTTP 1.1. But I'm not sure if if it makes sense for an API provider like Twilio to ever support it. But at least I never saw any benefit. Like for browsers, it's a completely different discussion. But for API providers, I never saw any difference.
And also, one of the benefits of Keep Alive is the whole memory and CPU consumption. If you leave a lot of sockets opened, like you spend less time opening and closing objects in your memory. So yeah. Anybody else? Okay, thank you guys.
Thank you, Chad.
Let's see, it's working. So next we have Deva. So now you have a big challenge.
I know, I'm finding it.
You have a big challenge with the pizza distracting everyone, but just bear with us and we will have pizza in a couple of minutes.
Well, some of them are going for it already, yeah?
No one is going for it.
No one's going
No, not yet.
It's going to be the first.
Thank you.
Hello, everyone. Can you hear me? Yeah? Excellent. Listen, Alberto said I should be gentle with everyone here and have a soft introduction to what my business partner and I do, Robbie's over there, and myself do. We work in the field of positive psychology when it comes to leadership development and when it comes to improving performances of teams and organizations, okay? It's not going to be so much of a lecture piece. I'm going to try and look at real-life scenarios that we've been involved in and how it will translate to managing teams, projects, DevOps here as well. There's much for me to learn about what you guys do, but I'm working and collaborating with a next-gen CTO now with a large company that you guys are all familiar with as well, to see how I can collaborate better with his teams when it comes to releasing products and releasing new iterations of software and all the rest as well. So I do have some understanding, but bear with me, there's much I have to learn as well. And again, give me 7.8 minutes or something, because I know the pizza is there and it's can only be so compelling, all right? I'm hungry, brother. I'm hungry too. Okay, so Filipe, where's Filipe? You said, Filipe was saying, he feels like he's an intruder. I feel like I'm more than that. I got my work cut out for me, but thanks for your patience, guys. All right, so Naidu Plus, what we do is we work on positive psychology for individuals and teams. Now, positive psychology is not about positive mindset and positive thinking and positive this, positive that. It's a science and rigorous way of finding heavy research and data as well, finding of better ways for you to conduct yourself, or for your team to conduct yourself, or for you to lead and manage projects or teams as well. So one of our mantras is find the upside to your downside. See, we have been hardwired to look at what will go wrong. Okay, that's in our DNA. Our ancestors, thousands and thousands of years ago in the cave, going, if I take a step out of the cave, chances are I'm going to die. Well, things are different. We're in Dublin. It's not that bad, right? So, things are pretty good. So, but we're hardwired, and maybe by society, maybe Dublin's a bit tricky. Come on, Casiano. Okay, cool. Well, I'm here to learn. So, we're hardwired, and sometimes it's society, sometimes it's family, sometimes it's conditioning that says, what do I do wrong? And a lot of organizations will focus on how to develop the needs of a person, the needs of a team. But my question to you, and if you guys are managing teams or managing yourself, is what are you guys doing right? What are your strengths? Have they been assessed? Is there a rigorous method to find out what your teams are doing right? How your customers feel about you? How your suppliers and vendors and partners feel about you, in a positive, in your best sense. Are those questions being asked? It's interesting, right? What are you guys doing right? What are your strengths? Okay? So, one of the great ways of finding that out is what's known as the self-determination theory, right? So, Desi and Ryan, these lads are major players in the positive psychology field, okay, in that spectrum. And what Desi and Ryan did, what the lads did, was they spent many, many years, and the research is still being updated by other people as well. They spent many, many years focusing throughout many cultures, cross-generational, many different age groups, in different stages in life and career as well. And they found out there was three inner compulsions and desires that we have, okay? One is to feel a sense of competence or mastery in our trade, in our craft, in what we do for a living, perhaps, or maybe if you're in academia, if you're still a student, okay? Even a child needs to learn how to walk. She needs how to learn how to read, and gets rewarded by her surrounding, thankfully, if her competence grows. This relatedness, most of us feel we need to be part of something larger than us, maybe a larger narrative, maybe part of a team, maybe part of a community, maybe part of a family. That's a very, very important driver as well. And then a sense of autonomy. Do we have control, some control of our life, some control of our life at work, some control of this particular quarter, this particular phase in perhaps product development or product launch, whatever may be the case. And the thing is, if you're managing a team, everyone regards it differently. So how do you measure that? How do you scale that? If you want to go from what we're doing, what our strengths are, and how can we go to the next level as well. So individually, see, sometimes when people turn around and say, yeah, everyone's on path, we got a goal to achieve, we're going to do it, but no one turns around and asks, well, what does each individual want to do it for? It may not just be for professional pride or for the nature of, if they've really bought into the culture of the company, it could be other reasons as well. So that's fascinating, right? And as an individual, perhaps consider it, picture it now, visualize it now. Are these important compulsions that you have instinctively to be better at your craft, at your trade, at your work, to be part of something larger, not just yourself, a larger community? and to have more control and purpose in your life, right? So SDT, self-determination theory. So how do I use SDT and hope theory and value stacking and a whole bunch of other models and frameworks as an entrepreneur? Okay, as an entrepreneur, we focus at Naidu Plus. We focus, in a sense, well, we're training for nine months now, yeah, Robbie. So we use a lot of startup models and sort of startup methods as well as we're growing. But we also release a lot of products, not just live coaching. So when we're doing product development. And again, as much I have to learn, I mean, but there is some similarity in the way we approach positive psychology coaching as well as in Agile. There's an iteration process, a way of looping. The journey continues. An individual is like, if we're developing an individual or team, we just don't turn around and say, this is the time frame at the upfront. It's about how to measure timelines as we go along as well. So there are some similarity between Agile and the way we do things as well. But, what I realize when I'm forming a team, for instance, okay, and as a startup, I've been given to a certain degree a bit of leeway in regards to that. Now, Robbie, I hope you don't mind if I use you as an example. Now, Robbie's background initially was in media, okay, creating content. Then, life being what it is, he went down a different path in career. We ended up working for a multinational together. Then we stepped away to start our own business. But I asked Robbie a series of questions. I'll be frank with you, over pints and over nights out and at work, over Mexican food and all the rest. And I found out that his key strengths weren't really given a chance to explore. He had other talents that he felt a huge compulsion in a sense of competence and in a sense of, in regards to that, for instance, part of the SDC, the self-determination code, those traits within Robbie wasn't allowed to flourish. I'm developing some salespeople at the moment. Now, some of them come from a sales background. Some of them come from engineering, from data entry. But we've done some testing in regards to them and realized that their natural traits and the compatible traits that they have will suit what most people don't regard as being a salesperson. But they have this inner drive to achieve that. So my question to you is, when you're clustering a team, and sometimes you don't get given this opportunity, are you clustering a team by job titles, by job responsibilities, or maybe are you allowed, and it could be a big ask, are you allowed on occasion to cluster a team, and you may want to get it from other parts of the software cycle or whatever, maybe the scenario, cluster teams on strengths that a person possesses, right? Or if you're in between other functions within the organization as well, and you're putting kind of a multifunctional team, can you find some other people and look at what strengths that they have that can be developed at a better level as well? Something to consider. How am I doing, Casiano? Not too bad. So from my experience, when I was launching this business as well, I went back to this. And what did I learn initially? I learned initially that whenever I'm launching a new product or launching a new service or starting a new business, I got a coach to coach me, because I was terrified at the start. All right? I was hesitant to take action. But I realized that my operating system, the way I functioned at the start, before I launch something, before I get into something, whether it be a marketing campaign or new product that Robbie and I are creating at the moment, is I feel a whole bunch of fear and I lose motivation. But I realize that only lasts for 2 or 3 weeks. So now I realize that's a recurring theme, and I try and find the upside to my downside, which is the fact that this is the way I function. It's okay to have fear at the start of when I launch a campaign or new product. So those questions aren't allowed to be asked sometimes, but when you put it through a framework of this nature, you go, that's fine, that's okay. But I want to measure it to a greater degree. So I turn around and say, okay, so my competence level is this level at the moment. This is how I want to relate with my team in the marketplace and my suppliers and my partners. That's actually a typo. That should say autonomy. And autonomy is like, how do I have more control over my life as an entrepreneur, as a leader, as a manager, as a coach, and also how can my team have a greater degree of control as well? So these kind of questions apply not just to you as an individual, but if you have a chance, consider asking it to your team as well. And then are there any kind of recurring trends or themes that arise? During a period of launching a product or creating a new solution whether it be internally or externally, do your team members function a certain way at the upfront? Is time management a concern for some of your people? And is it more a case of, is it energy management? So when you're using something like the SDT, the self-determination theory, as a framework of questioning, are we getting more competent? Are we getting a chance to express ourselves the way we want to on a daily basis? Are we relating ourselves in the right way as a team? It gives you a little bit more of a discerning kind of framework to ask questions. Now, so as I just circling back before we finish, so I realized, for instance, in challenging times, I became quiet for the first few weeks, but it's only so I can determine a solution, right? But now I tell it to my team, it's okay, all is good. I'm just trying to determine a solution the best way for us together, and we can brainstorm about it together as well. So, fundamentally, the gist of it is the fact that if you can focus on your strengths, plug it into some of the positive psychology frameworks, if you're curious about it, it'll be an interesting way to lead yourself and probably manage your teams and manage products as well, product development as well. Okay, among other things that you guys do. So, and upon doing that, and if you guys want to touch base with me later on, through direct message, or have a chat over pizza and all the rest, there are ways you can start programming mantras for yourself to kind of guide yourself more effectively and productively during the day as well. And you can even start doing it for your teams, if your teams want to write some of these goals as well down. So again, if self-determination code kind of resonated or you're curious about it, hope theory plugs in really well with it. All right, hope theory is about multiple pathways to achieve a goal. And then you can check out values-based goal selection and stacking as well. Many a time, people want to achieve the same goal, but you got to talk about your team about why they want to do it, individually if possible, and then stack it and create a whole bunch of different importance around it as well. Did that make any sense? Did that make any sense at all? Okay, so is that like a soft approach? A good invitation to positive psychology and what we do? Is there any questions? Any questions? Yes, sir.
The self-determination, everybody is with different motivations at that time. So how do you measure self-determination? Like forming and storming. Like storming is the most the conflict side.
When you form a team, you mean in relation to that? Okay.
Yes. So how do you deal with that when you are just thinking that of yourself at that mind? Your mindset is, I'm the most important person.
Yeah, okay. Well, if that's your mindset, that's your mindset.
Yes.
That's what
in every team.
Yeah, no, but that's the thing is, see, I would turn around and say, how can we use that as an asset? If it's not me, if it's one of my team members, how can I use that as an asset? If she or he regards themselves as being a priority, how could I plug that in or amplify that as a strength? Or may have to dial it down and kind of rechannel it. See, another thing is also if you're inheriting a team and building a team is two different things as well. When you're building a team, you can be a bit more specific how you form the team. Now, you're not always going to get the kind of people you want, the resources you want, but that also is a different question in regards to inheriting a team. So my question to you is, my answer to you, or a possible answer to you is, if this person feels that they are the priority, measure it. In what sense do they think they are a priority? What are they trying to determine and acknowledge it, in that sense? And that's a problem. That is a problematic concern that we all have to deal with as well. So, how can we measure in what way do they want to be acknowledged? Recognition or reward in regards for them to be regarded as someone of prime importance in the team? Does that answer the question a little bit? Okay, did you want to continue with another question? Okay, anyone else got a question? We can circle back later over pizza and talk about it if you want, man. Because it is a good question. Anyone else?
No more questions? Thank you very much. Now we can have some pizza.
Guys, thank you so much for your time. Let's keep in touch.
Thank you for your presentation.
Thank you.
Welcome, everyone. Thank you.